Okay, in this example, we are going to write these fractions as decimals. Now, there's a couple of ways that we can do this. One of the ways is to have a look at the denominators and see if we can make them a power of 10 by creating an equivalent fraction. On first glance, they don't look like that we can, so we have to do it another way. But the first one, for example, if we look at 8 as the denominator, if you think hard enough, you will know that you can multiply 8 by 125 to then get 1,000. So that is possible, but really multiplying by such large numbers, you're going to need a calculator, and then from there, if they are a power of 10, then you can convert them to a decimal quite easily. So for the first one, I'll show you how to do it, but for the second one, I'll show you a different way to do it if you can't get a power of 10 for the denominator. So let's consider the first one here. So it's 3 3/8. Okay, so if we look at 3 3/8, we can multiply 8 by 125 and 3 by 125 to get a power of 10 as a denominator for A. So here it would be 1,000, and 3 times 125 is 375. And if we go ahead and look at that, now this can be converted quite easily once you knew 125. So from here, 375 divided by 1,000, you can see will give us a decimal of 0.375, and since there's a whole number of 3, it would be 3.375. So that's how we can convert that quite simply. The other way to do this, if you did not know that 125 was there, was to basically just go ahead and do a division. So here it would be, the fraction part would be 3 on 8. So we would be taking 8 and dividing that into 3. And you might think, how can 8 go into 3? Well, yes, it can go into parts. So you're just creating some decimal values, and we're saying how many times does 8 go into 30. So there's a 0 point at the top here, and it would be 3 times, right? So 3 times with 6 left over, because 8 times 3 is 24. 30 minus 24 is 6, so 8 into 60 goes 7 times. 8 times 7 is 56 with 4 left over, so 4 here. And fortunately enough, we don't have to go any further because 8 into 40 goes 5 times here. So then we can then say 3 3/8 is equal to, with the 3 whole number, 0.375. So these are the two ways to do it. Okay, when you look at example B now, example B, I can't really think of a power of 10 that can be divided by 13. So we're just going to use the division method for this. So what we do is we take 13 divided by 5. Not sure how far we're going to go yet, but we'll just put 2 zeros for now. So, and the decimal place goes at the top too. So 13 into 50 here goes 3 times, and that's 39 with 11 left over. Okay, so we've got 13 into 110. So at this stage, because a lot of our numbers go beyond our 12 times 12 times table list, you can use your calculator for this one here. So we're basically taking 111 and dividing that by 13, and we know that we can get 8 out of that, because 13 times 8 is 104, and we have 6 left over. 13 now into 60. 13 into 60, or if we divide 60 by 13, we get 4. So we have 4 here, and 13 times 4 is 52, so we would have 8 left over. So you can see that this will tend to go on for a little while. If this decimal goes on and it doesn't repeat itself, then you could pretty much stop at a certain point. But we're just going to keep going and have a look at where this goes here. So if I just complete the rest here, I can show you what it actually looks like without having to bore you through the details. This is what you're going to get here. And 3. Okay, so at this stage, you will notice that we have a 3. So this 3 should signify something to us now, because if we have a 3 here, guess what? We're going to go through this sequence all again, aren't we? Because if we have a 3, the next remainder after that will be an 11, because 3 times 13 is 39 and 11 remaining, and then we will just basically be repeating this whole sequence again. So this here is called a recurring decimal, where the numbers after the decimal place tend to repeat itself. So sometimes you can have, 1/3 is recurring, so it's 0.3333, the 3 recurs. Sometimes you can have two numbers recur, so 3/11 is 0.272727, so that recurs. In this case, we have quite a long number of decimals that start to repeat itself. So here we're just going to say 5/13 is equal to 0.38465, and you can do this two ways. One of the ways is you can draw a line at the top to say that those repeat itself, or you can actually put 2 dots at either end of those numbers to say that this whole sequence of numbers repeat itself. So that's how you can convert fractions to decimals, using a division method, or using an equivalent fraction method if you can make your denominator a power of 10.